everyone, this is Krish Kulkarni and you're watching Cosmic Science. In previous video, we have seen with the example of aeroplane how work, energy and power are correlated. Also, we have discussed the tools which are required to study work, energy and power. Those tools are vectors and scalars. We have seen multiplication of scalars, multiplication of vectors. Today we'll be discussing about properties of scalar multiplication. We'll see how scalar multiplications, components of the scalar multiplication, that is vectors, how they act, how they perform the operations. We'll see in this video. Let's get started. Properties of scalar vectors. Suppose I have a vector A and vector B. To find a scalar vector, to denote a scalar vector, we need to add dot in between A dot B. A vector dot B vector, which represents product of the scalar vector. It is given by A B cos of theta. Here theta is the angle between these two vectors, vector A and vector B. Let's see what is commutative property of vectors. First one, commutative property. If I have a vector A, if I have vector B, which is given by magnitude of A and B and cos of theta. This is a dot product of two vectors vector A dot vector B, which is equal to vector A and magnitude of vector A and magnitude of vector B and cos of theta. So we have this one vector, one multiplication of vector. We'll see another multiplication pattern. Vector B dot vector A will be B into A cos of theta. So you may wonder that value of A dot B will be different from A dot B dot A. You may wonder this, but it's not. Let's see. It will uh, dot product of vector B and dot product of vector A. It will be same. Let's see how. Vector product of B dot vector product of A will be equal to BA cos theta. This is the magnitude which can be written in A and B. If you multiply A and B, B and A, the answer will be same. So A B cos of theta. This value and this value are same. What does this mean? Uh, Scalar product of vector A and scalar product of vector B is equal to scalar product of vector B also into or dot product of vector A are same. So this is about commutative property of uh, two scalar vectors. Now what if if there are three vectors and their multiplication. How does it happen? Let's see here. Vector A dot vector B plus vector C. This will be equal to magnitude of A, magnitude of B plus magnitude of C into cos of theta. I have written in this form. This is a vector A, and this is a another combination of two vectors, vector B and vector C. I have taken the magnitude and cos theta. So now let's simplify this one. It is equal to AB cos of theta plus AC cos of theta. So what you can see here, AB cos theta, what it will be? It will be A dot B cos of theta. And what it denotes? It is a denotation of scalar product of A dot C. So this is this property of vector of multiplying three different vectors, vector A dot vector B plus vector C. When you take a dot product of this, you will get this answer. So, so this property of two or three vectors is called distributive property. Distributive property. Multiplication of multiplication or dot product of three vectors will give you this answer. So this is called distributive property. So the question arises, when two vectors are parallel to one another. Here it is. If vector A and vector B are in the parallel to one another, what will be their angle? 0, right? Vector A dot vector B equal to AB cos of vectors are parallel. The angle between the two vectors is 0. Cos of 0. So simplify this term. A dot B AB cos of 0 is 1. So we get A AB dot product of vector A and dot product of vector B will give you magnitude of these both the vectors. This is when two vectors are parallel. So suppose two vectors are same, they are equal. Vector A and another one is equal to vector A itself. Let's see what happens, what value we get. Let's see. Vector A and same vector A. These are the two same vectors equal to A into A cos of, if two vectors are if two vectors are equal, what will be the angle between them? 0, right? So if we simplify this, we get vector A dot vector A equal to A square. A into A, same magnitude, square. Cos of 0 is 1. So this is the value we get square. When you take a dot product of two same vectors, you get square of the magnitude of the two vectors here. Suppose suppose if two vectors are perpendicular to one another, if two vectors are perpendicular to one another, what will be their angle? It will be 90-degree. Let's see how it goes. Vector A dot vector B equal to AB cos of, what will be the theta value? If vector A is here, another vector B is here, vector B, vector A, what will be the angle? 90-degree. So cos of 90, what is the value of cos of 90? 0. It will be a, this whole term becomes 0. So the scalar product of two vectors which are perpendicular to one another is 0. So what about the vectors? How about the only excluding the magnitude? How it will apply for only vectors? If the vectors are at 90-degree, how will they? How much value they will show? Let's see in this ahead. Vector I dot vector j. These are the unit vectors. Vector I and vector j are the unit vectors. So magnitude is 1 into 1. Cos of theta. I and j are perpendicular to one another. Cos of 90 is 0. Cos of 90-degree equal to 0. What is the value of j vector dot k vector equal to 1? Magnitude is 1 into 1. Cos of 90-degree equal to 0. What when we multiply vector k with I, it will be 1 into 1 cos of 90-degree equal to 0. So we need to remember dot product of vector I and uh, vector j is 0. We need to also remember dot product of j and with vector k, it will be 0. Dot product of vector k along with vector j, it will be 0. So these are the properties of scalar product. Let me recap. We have seen commutative property of scalar vectors, distributive property, and when vectors are parallel to one another, when vectors are equal, when vectors are perpendicular one to each other, we have seen their particular values, how they operate, how the values are based on angle. We have seen. This was about today's video. We have covered right now from from example of plane which describes the intercorrelation of work, energy and power. We have seen scalars, vectors, scalar multiplication, vector multiplication, properties of scalar product or scalar multiplication we have seen here. So if you have understood the content, if you are happy with the content, please drop down your comments. Please hit a like button and subscribe so that it can reach to many other people who are interested as you are. So with this, I would like to conclude the video. See you in the next video with the next topic of the same chapter. Till then, be safe, be healthy, stay calm, work hard. Thank you.